Hello and welcome back. It is time once again to fix something. And today we've got something a little different, at least for me. I've never touched one of these before. This is a PS5 that I bought, broken, non-working. We're going to try to bring it back to life. I've never even seen one of these in person until now. So I'm not really sure how to take it apart. I've been watching some videos how to get these covers off and stuff. But this is a no power. Maybe we can just test that out. It's supposed to be totally dead, no power, doesn't do anything. Let's see. And that seems to be pretty true. Doesn't do anything. What if you put a disc in it? I'm not sure which way the disc goes in it. Does it go like this or this way? Doesn't seem to be doing anything. The only issue I'm worried about, you might say, is that the person I bought it from said they had taken it to somebody else and they weren't unable to fix it. So I'm wondering what they have done. You know? Well, we won't know until we get in there and take a look at it. So I'm going to sit here and struggle for a while off camera, getting these covers off, and we'll see if we can get down to that main circuit board and power supply. Probably going to be a few minutes. I'll bring you back when I'm through fighting with it. All right, our PS5 is now in more pieces than it was, so I guess that's progress. That's a lot of screws. A lot of screws holding that thing together. I used to think PS4 Slims were hard to get into. Nope. All right, what I'd like to do now, I'd like to see if the supply is working. I'm pretty sure they would have checked the supply, but, you know, not like it's going to cost me a whole lot to check it. So let's check it. Are we getting 12 volts? I don't know which one's positive, which one's negative in here, so take a chance. There we are, 12 volts. Now, so where do we go from here? Well, I think I've still got to get the other half, the metal plate off of it here. The heat sink's still attached to it. I'm going to have to separate that and get this in on the workbench and see if we can find a short or something. Well, we are inside at the workbench, and I've put a little plastic cover I had. Found something to put over this so it wouldn't mess up the liquid metal, because I know I'm going to be turning the board around and over, and I'll sure enough put my hand in it or spread that around somewhere. So what I have noticed so far is that we have a lot of flux residue right over here, and that's kind of worrisome. So I don't know what they've done, if they've messed with the south bridge. I'm thinking that's the south bridge, not positive, but yeah, a lot of this looks like stuff that would be related to standby power, which is probably where you need to look, but I'm a little concerned now about what all has happened to this thing. Alright, well, I'm in here hunting around trying to find something, and I was able to find online a diagram showing some of the standby voltages. I did not make this, it's not mine, but somebody was generous enough to share it. I want to show you right in this area, right in here. See where it says 1.8 volts? 1.8 volts, right in there. It looks like, you can see that little feed through, that little vias right there. That looks like a supply coming in. So I'm guessing 1.8 volts should be coming in there. And these are in standby mode, not when powered on. So I should have them right now. And what I'm doing, if I can get ready to show everything, I'm feeding 12 volts from a supply over here, just to check, because I'm not trying to run the whole thing. I'm just trying to provide standby power, so that supply can handle that. And I'm missing that 1.8, and I wanted to show you. Maybe we don't have to go into the microscope, but we may have to. I just wanted to show you. I've got my meter in. Let me go to my meter in resistance mode right here. Okay, and I've got my probe on ground. Let me see, where was I going? At this point, yeah, right here. Let me get the picture under the microscope. It's always a battle. Anyway, you can see, oh, out of focus. That point right there. It's supposed to be at 1.8. I don't have power on right now, but let me show you what it measures resistance to ground. Well, now it's 2K ohms. I swore I had like 12 ohms there just a moment ago. Maybe I had my power on. Let's just see. Maybe I'm just crazy. Let's go ahead and turn some power on. 12 volts. She's going to draw like 30 milliamps and then drop back down. Let's see that same point. There's no voltage there. And I thought I had a short there earlier, but maybe I'm just crazy. But I'm on that point. It should be 1.8 in standby mode. We have 12 volts applied, and I'm not getting anything. So I have a feeling we find the source of that 1.8 volts, we'll find our problem. Okay, where are we now? That 1.8 there that I thought I measured 12 ohms on, it's not 12 ohms, it's in the K ohms. I had, the power was on. So with the power on, of course, you get weird readings. So that was that. So that's not shorted. 1.8 it's not shorted. But it does look like the 1.8 comes from this little IC over here. Because you can see it, well, he's got a blue line right there. I think this one here generates the 1.8 from 3.2, 3.3 in. And I don't have that voltage, which is strange. I do have it over here in what I believe is the standby power IC right here. I do find it there. It does exist. It's being generated. So I can't help but assume that it gets switched in some way into that low dropout regulator on the other side. And that may be the tricky part. How does it get there? Because apparently it's not hardwired there, you would have it. Well, it's the next day, and we are back out in the garage. So I worked on this thing for several hours off and on yesterday, and made some progress, and I wanted to share it with you. So what happens when I press this button? If I can press it. There we go. Look at that. Look at that. And that. Yes, ladies and gentlemen, we have a working PS5. And I will show you what I had to do to fix it. I got very lucky. But, yeah, we're working. I don't have a controller for this thing, so I'm going to turn it back off. But we are back alive. And I will take this board back out now, and back to the workbench, and go over what I had to do to fix it. We are back at the workbench, and I want to point out to you what I had to do to make this thing work. Earlier on when I first brought this board in to be looked at under the microscope, I noticed flux around this IC right here. This is RT5126, which generates several voltages. You can see that's what I measured early on, was those three voltages: 1.15, 1.98, and 3.3 volts. But it may have been responsible for making more, that it wasn't working. I don't know. But all I had to do, well, to begin with, it was drawing like 30 milliamps, and then would go back to zero off the 12 volt supply, like 30 milliamps and back to nothing, and 30 milliamps. It was kind of cycling in a weird way. But I don't know what's normal for these things. First time I worked on one. But that didn't look normal. But I removed this IC because some of the solder joints did not look very good. It had obviously been removed. I don't know if it's been replaced. I don't know. But I removed this IC, redid the soldering, retinned everything with good good leaded solder, and put it back down, the same IC, and then tested it, and that cycling was gone. It changed its behavior. Now, it still was not working, and then the current draw was only like 9 milliamps. It didn't seem to do anything. It was just stuck at 9 milliamps, I believe it was. So I kind of thought, I've made this worse. But it did change the behavior, and that's what was interesting. It changed the behavior when I resoldered this IC a little bit better. So then I got to thinking, there was another place on the board where there had been some previous work done. And let me show you if I can. Let me flip this over. This IC on the other side, right up here. See if I can get it in the microscope shot here. Yeah, this one. That's marked SBV, which appears to be a Texas Instruments switching IC. That one had some solder in it. You can still see this. I don't think I've cleaned it up too well. This capacitor is a little bit askew over here. But this IC had obviously been removed. So I removed that one, redid the soldering, and put the same IC back down. And then while I was in here on the bench, I gave it 12 volts, hit the power button, and it seemed to be trying to come on because my power supply went into current limit. It couldn't supply enough current. So that was like 11 o'clock last night. And I'm like, it's getting late, but I need to find out. I took it out in the garage, put it in the chassis, and sure enough, she booted right up. So I don't know if I'm guessing that they must have pulled these parts off of donors, and they had the right idea, but the soldering just wasn't quite good enough to to work. But that's all I've done. I did not have to find any parts, luckily, because I don't have any parts, don't have a donor. And that RT5126, if you search for that thing, nothing comes up. So it's like not available. Not yet, anyway. It's too early, I guess. But that SBV chip, that one, I don't know, maybe available. It's a Texas Instruments. It appears to be a common part. But yeah, that was it. I just basically redid somebody's poor soldering, and now it's a working PS5. So I'm going to sit here, I think, and hook some supply voltage back up and take a lot of measurements and make a lot of tests, because this is the first one I've messed with. Just make a lot of notes for the next one. So maybe I can be a little faster about it next time. It always helps to have notes. But I hope that was in some way interesting or educational. We do have a working PS5. If it was, please give me a thumbs up. And I will be encouraged to see you in the very next repair. So long for now.